Good day everyone, and for today's video, we're going to discuss about the normal distribution. So this is what normal distribution looks like. This is sometimes called bell curve because it looks like a bell. A normal curve as well because from its original term, normal distribution. And we can also call this as Gaussian curve because this is one of the contribution of the mathematician Carl Gauss. The normal distribution describes approximately many phenomena that occur in nature, industry, and research. In order to understand the normal curve, we need the following symbols. We use this Greek letter mu. It stands for the mean. And also, a Greek letter sigma to indicate standard deviation. You can use normal distribution to determine the probabilities of continuous variables such as volume, height, weight, and even the grades. So mean, it tells you the middle part of the normal curve as you can see on our illustration class. This mu located at the middle or at the center of our normal distribution. And standard deviation tells us the spread of the normal curve. Let's talk about the properties of normal distribution. Number 1, the curve is symmetric about the vertical line which contains the mean. To illustrate that, let's have our normal distribution. Whatever happens on the left side also happens on the right side. Number 2, the mean, median, and mode have the same value. So if this is the mean, the center of our normal distribution, whatever the value of the mean, that will be the value of the median and mode as well. Number 3, the curve is asymptotic to the horizontal axis. That is, the curve extends indefinitely in both directions. If this is our normal curve, let us extend this and zoom to the right. So this is what it looks like. As we extend this indefinitely, as you can see, the curve will never touch the x-axis. Number 4, the total area under the normal curve is 1 or 100%. That means on the right part, we have exactly 50%, and from the left part, we also have 50%. Why? Because from property number 1, the curve is symmetric about the vertical line which contains the mean. So whatever happens to the right part, that will be also the case from the left side. Number 5, low standard deviation means the normal curve is shrinking and the data points are clustered to the mean, while a high standard deviation indicates that the normal curve is stretching and data points are scattered to the mean. To illustrate this, let's say we have a couples of normal distribution. So the distinction between those curves are labeled as follows. We have red, whose standard deviation is 0.15, green, normal curve, whose standard deviation is 0.2, and blue, yellow, purple, and black, whose standard deviations are 0.3, 0.4, 0.5, and 1 respectively. The height of the normal distribution refers to the likelihood of a certain event. On this location, the event is more likely, while on this location, the event is less likely. Let us have an example of normal distribution in real life. In this case, we have the average height of male Filipino students. 5 feet and 5 inches or 5'5" is the average height of the male Filipino students. So on this location, this will be the average height, which is the 5'5". On this location, we have the small, and for this part, we have the tall. Since this is the 5'5", we can consider this as 5'4". This is your 5'4". This is your 5'3". 5'2", 5'1", 5 feet, 4'9", 4'8", 4'7", and so on. So let us have this as 4'8". Okay. Now, on the right part, since this is our average height, which is 5'5", we can consider this as 5'6", 5'7", 5'8", 5'9", 6-footer, 6'1", 6'2", 6'3". So let's say this is our 6'3". Here, it is very rare to see male students whose height is very small, such as 4'8", 4'7", and 4'6". On the other hand, it is also rare or very rare to see male students who is really tall, such as 6'3", 6'4", and 6'5". So that means it is often for us to see or to encounter such students whose height is 5'5", 5'6", or 5'4". On average, 66 inches is the height of male Filipino students. So mu is 66. Let's have 66 on our center of the normal distribution. And let's say that the standard deviation is 2. So remember, standard deviation indicates as the spread of the normal distribution. Now, since standard deviation is 2 or sigma is 2, that means from 66, we have to travel 2 units to the right. So we have 66, 67, 68. As well as to the left, we have 64. So that is 1 standard deviation away from the mean. So from 66, we're going to 70. 66 plus 4. Or 66 minus 4. That will be 62. And we have 2 standard deviations away from the mean. At this time, let's have 72 to the right and 60 to the left. So from 66, we are 3 standard deviations away. Now, to fully understand this example, let us have the concept of 68, 95, 99.7 rule. This is the 68, 95, 99.7 rule. Let us start from 1 standard deviation away from the mean. So that is 68%. Okay? That means 68% of the height of male Filipino students are between 64 to 68 inches. If X is a random variable whose values are the height of male Filipino students, we can say that the height, or I mean the probability that the height of the male Filipino students between 64 to 68 inches is 68%. Or we can write this in mathematical way. Just like this. Next, if we consider 2 standard deviation away from the mean, we have 95% of the height of male Filipino students are between 62 to 70 inches. Or we can rewrite this in mathematical way, just like this. Next, let us consider now 3 standard deviation away from the mean. And that means we have 99.7% of the height of male Filipino students are between 60 to 72 inches. And again, we can rewrite this as follows. Now, you might be wondering, what if we calculate the probability for standard deviation away and 5 standard deviation away? And the answer is yes, you can. Remember, the normal curve does not touches the x-axis. You can go on forever. Both directions as well. So you can go as many standard deviation as you want away from the mean. But remember, the area within these regions is very, very small. Let's have the drill. The normal distribution below has a mean of 30 and a standard deviation of 1. Approximate the area between 28 to 30. As you can see, the gap between these numbers is 1 since the standard deviation is 1. So this is the mean. From this value, we're going to travel to 31. So that is 1 sigma. Over here, 30 to 32, we have another sigma. So the distance from 30 to 32 is 2 sigma. And lastly, we have another sigma from 32 to 33. And we have 3 sigmas in total. So that means this is 3 sigma. So let us have our line segment from 28 since we're going to start from this value. Now, what happens to the left also happens to the right. Remember, 2 standard deviation away from the mean is 95%. Since we are looking for 28 to 30 only, we're going to divide this into 2 equal parts to eliminate this region. So, we have 95% divided by 2. That will be 47.5%. And that will be your desired area. Now, in terms of probability notation, we can express this as probability of x from 28 to 30 is 0.475 or 47.5%. Number 2, draw a normal distribution whose mean is 7 and a standard deviation of 0.4. Approximate the area at most 8.2. So this is your illustration. The mean is 7. Okay. Mean is 7. And standard deviation is 0.4. So that means we're going to travel from 7 to 7.4. 1 standard deviation away. Again, whatever happens to the right, that will be also the case to the left. So here we have 6.6. From 7.4, we have to add 0.4. So we have 7.8. Now, from 6.6, we have to subtract 0.4. So on this part, we have 6.2. And so on. Now, observe that we have a term at most. So on our example, we have at most 8.2. That means maximum. So the maximum value in our normal distribution is 8.2. And this is the desired region. This is the entire area we are looking for. Now, this is 49.85%. Why? Remember, 3 standard deviation away from the mean is 99.7% based on 68, 95, 99.7 rule. So this is 3 standard deviation away. Why it is 49.85? So we have to divide this into 2, which is the 99.7%, and the result is 49.85%. And the total area under the normal curve is 1 or 100% based on property number 4. So that means this is 50%. Thus, the total area is 50% plus 49.85% is approximately 99.85%. In terms of probability notation, we can express this as this. The probability of x less than or equal to 8.2 is 0.9985 or 99.85%. And that is it for our normal distribution discussion. If you have any questions or concerns regarding to this video, kindly comment down to our comment section below. That's all. Thank you and God bless everyone.